Welcome to Rajashekhar classes on applied data science with Python. This is lecture number 402. In this lecture, we will try to understand overfitting and underfitting. So, as we have seen in our previous lectures, in decision tree, as depth increases, what happens is the possibility of having very few points at a leaf node increases. Imagine if I have a decision tree like this, very deep. Is it not very deep? So let's assume I have 1000 points at this particular position. Let me say I have 1000 points here and let's assume 600 points here. If I have very deep tree, isn't it? What could happen here? I may just have 2 points. Let me say I may just have 2 points here. Let me assume I may just have 2 points here. Very few points. Literally very few points literally. So if I have very few points and if all these points are noisy, let me assume all these points are noisy or errors, then in my decision tree learning, I'm still coming to here. I'm still building the tree, isn't it? Still I am building the tree. If the 2 points, if the 2 points are noisy, then basically overfitting the model, isn't it? It overfits the model. I am basically overfitting my model to noise. So as depth increases, your possibility of overfitting increases because this sparsity of the data at a very deep level is very high. Remember, as depth increases, the other thing that happens is the interpretability of the model. Interpretability of the model also decreases because it is very hard to somebody to understand. Why? Because as depth is increasing, they must understand this if condition. If there are so many conditions, there are a lot of conditions like this, isn't it? Because each of this condition is creating a condition. Each of them, this is creating a condition, this is creating a condition, this is creating condition, each of them is creating a condition. So we have lots of conditions. It becomes very hard to somebody to interpret why you gave a class label yq for a given query point xq, isn't it? It is very hard to interpret why you are giving a class label yq for a given query point xq. The more it becomes, the harder for us to interpret what's happening here in the model. At the same time, what if the depth is very low? Isn't it? That's what happening in this model. If depth is very high, this is the case. At the same time, what if the depth is very low? What is the minimum depth? This minimum depth is 1, isn't it? What is the minimum depth? Minimum depth is, it must be 1. Isn't it? Minimum depth equal to 1. So if a tree has depth 1, what is depth of this particular tree? It's a depth of 1, isn't it? So you will break it only by one condition and you say these are all, let me say, these all are positive points, these all are positive points and these are all negative points. In some cases, what happens here, especially when you're building shallow trees, you could run into situation like this. Suppose I have 1000 points. Let me assume I have 1000 points. Let me assume I have 1000 positive, let me say I have 100 positive points. Let me assume I have 100 positive points and 100 negative points. Let it be, isn't it? I split it. This is my data set D. What is my data set? This is my data set D. I split it by some feature, isn't it? I have data set D. I am splitting that data set D into D1 and D2. What is my D1? suppose D1 has 70 positive points, 30 negative points. Here in D2, if I have 30 positive points and 70 negative points, none of these nodes are pure nodes. Why? Because pure node means what? It must have only one class related data points. So this is important to understand. Here D1 and D2 are not pure, but let's assume, suppose we don't want to build a tree more than this depth. Then what do? We just stop it. Isn't it? We don't want to extend this one. What is the depth? This much depth only. I don't want to extend. I don't want to continue construction of decision tree. If a query point xq, let me say, if a query point xq reaches here, let me say this query point reaches here. Isn't it? If query point xq reaches here, what is the majority here? Majority is 70 positive points, 30 negative. Majority is 70, isn't it? Majority is positive points. So that I will declare, in this case, I will declare yq as positive label. Since here are the majority of the points, for example, if your xq is this one, here what is your yq? Majority points is negative points. Therefore, your yq will be what is your yq will declare as negative class. So especially a tree of depth 1, there is special name for it. It is called decision stump. There is a special name for tree of depth 1 is decision stump, isn't it? What is this? It is just like a cricket stump, isn't it? It's a decision stump, isn't it? It's just like 2 wickets. It's a 2 wickets cricket stump, isn't it? Depth equal to 1. What does it mean? I can say depth equal to 1 equal to decision stump. Isn't it? So it is literally like a stump. It's look like a cricket stump with 2 wickets, isn't it? When you don't have a clean node or pure node, you take the majority vote. So oftentimes depth is what you need to determine using cross validation, because you don't want it to be too deep, because too deep basically means overfit, and too shallow or your depth is very small, you are going to be underfit. So the right depth needs to be discovered using cross validation. If you look at it geometrically, just see, don't have to clean what does it mean? How will you determine your depth? That's what I'm saying here. Just see, don't have a clean node or pure node. Here you don't have clean node, don't have pure node. In that case, what you are taking majority vote. Here majority is 70, here majority vote is positive, here majority vote is negative. Isn't it? How can I calculate depth? Depth can be determined, depth can be calculated using cross validation, isn't it? Geometrically speaking, what does it mean? What it says? That's what I am saying. Depth is used for what? Depth can be calculated by using cross validation. Too deep means overfit, too shallow means underfit. Geometrically, what does a tree of depth 1 means? This is my feature 1. Let me say this is my feature 1. This is my feature 2. A tree of depth 1 is basically implies a tree of depth 1 is basically implies let this is the hyperplane. This is my hyperplane. Let this is hyperplane, and I am saying everything on this side of the hyperplane, everything on this side of the hyperplane is positive points. Everything on the side of hyperplane is a negative point, isn't it? And this hyperplane is axis parallel hyperplane. This is axis parallel. This is known as axis parallel hyperplane, isn't it? This is what's happening, especially decision stump. What if I have depth is lot, and this is my, let me say like this, what it says. If I have depth and my, let me say, if depth increases, what happens? This is my feature 1, this is my feature 2, I have 2 features, isn't it? If my depth is large, what's happening? I am breaking up my tree into multiple regions. Just see, this is one hyperplane, isn't it? Now what happens? Just see, I am breaking up my tree into multiple regions. I am breaking up my regions literally into multiple subblocks. Just see, I am dividing, because look at it, every plane here is axis parallel, and I can break up my plane into multiple ways, and it could say, it happens that there is one region like this. Let me say, just I am breaking into different regions, isn't it? In that case, what happens? It could there is one region. You if I keep on breaking, what happens? Just see, there could be a region like this, there could be a region like this, isn't it? I have one point, and where a query point, let me say, what I am doing here, there is one region like this, there is one region like this. Then what happens? I have only one point here, only one point, isn't it? I have only one point, and whenever a query point falls in this region, whenever a query point falls in this region, I am only using one data point to determine its class. I am using only one data point, to determine class, isn't it? To determine its class label, isn't it? This is sort of k nearest neighborhood. This is sort of k nearest neighborhood with k equal to 1, with one nearest neighbor. If one nearest neighbor, if you think about it intuitively, what happens? You are going to overfit. As this region becomes smaller and smaller, as this hypercubes become smaller and smaller, as you have fewer and fewer points, isn't it? The chances that one point is the outlier, which is overfitting also. Let me say, if this is outlier, what happens? Outlier point, which is overfitting, isn't it? Overfitting also increases. So geometrically speaking, an underfit decision tree is basically where you have very few hypercubes, whereas an overfit, just see this one, this is an underfit thing. This is underfit. This is underfit, isn't it? What about this? This is overfit, isn't it? An underfit decision tree, geometrically speaking, an underfit decision tree is basically where you have very few hypercubes, whereas an overfit one is, or you have lots of hypercubes or hypercuboids, and hence you are going to overfit. Very simple idea. Depth is probably one of the most important property. If you keep depth too low, you are going to underfit. If you keep depth too large, you are going to overfit. So the right way of to determine the right depth would be using cross validation. Just go through this lecture and try to understand. If you have any difficulty, please keep a comment. Thank you very much.